Okay, so guys, now in this video we have to find the derivative of y is equal to x multiplied by Euler with an exponent sin x. Okay, so let's just rewrite this function. Y is equal to x Euler sin of x. Okay, so the sin of x is actually present in the exponent. Now Euler sin of x, we have Euler exponent function. So when we have Euler exponent function, so we can find its derivative as Euler fx multiplied by the derivative of the same function. And then these terms are being multiplied, so we can use the product theorem. So the second function as it is derivative of the first function plus the first function as it is derivative of the second function. Now let's just apply the differentials on both sides of the equation. D by dx y, d by dx x Euler sin of x. So let's just simplify. This thing right over here will be my fx, the first function, and this thing right over here will be my gx, the second function. So the second function as it is derivative of the first function, the first function was actually x, then the first function as it is derivative of the second function. All right, then we have Euler sin of x, and these things will be cancelled, so we are left with a 1 plus x. Now the derivative of Euler sin x will actually be, first of all we will write this term as it is, so Euler sin of x, then we will multiply this term by this function right over here, so we can write d by dx sin of x. Then we have Euler sin of x plus x Euler sin of x. The derivative of sin of x is actually cos x, so we have Euler sin of x plus x. We can multiply this x right over here, so we have x cos of x multiplied by Euler sin of x. Now again we can take out Euler sin x common because it is present in both of these terms. So if we take out Euler sin x common, over here it will be divided as a whole, so we are left with 1 plus x cos x. The Euler sin x will be cancelled out because it is taken out as a common. And yeah, let me just clear one point right over here. When we take out the derivative of sin x, it is actually equal to cos x multiplied by the derivative of the same angle. Okay, so the derivative of the same angle over here specifically would be cos x cancelled by x, it would be 1. So I didn't write 1 over here because it was obvious actually. Okay, so I hope they get the point.